What's up everyone, welcome back. Patrick here, moving on to another example dealing with combining functions. So if f of x equals the square root of 3 minus x and g of x equals the square root of 2x minus 3, find f plus g, f minus g, f times g, f over g, and then g over f, and then state all of their domains. So let's go through them one by one. So first we got f plus g. So that's going to be what? Just the two functions added together. So the square root of 3 minus x plus the square root of 2x minus 3. Right? And notice that we can't really simplify this any further. These are not like terms. The expressions under the square roots are not the same, so we cannot add them. And so from here, what we can do is we can figure out what is the domain going to be. Now, with a square root, unless it's in a denominator, like f over g and g over f, which we'll get to, if it's just like this in the numerator, then we always know that whatever expression is under the square root, that expression always has to be greater than or equal to 0. Right? It could equal 0 because the square root of 0 we can do. That would just be 0. And it could be positive because the square root of a positive number would give us a respective number, but this can't be negative ever because you can't square root a negative number. So here what we would have to do is we got to take both of these separately and we got to figure out when is 3 minus x greater than or equal to 0 for this square root, and then when is 2x minus 3 greater than or equal to 0. So notice here this is going to happen when x is less than or equal to 3. Right? We'll bring the negative x over. And then over here, we got 2x has to be greater than or equal to 3, and then x has to be greater than or equal to 3 over 2. So notice that x has to be less than 3, cannot be greater than 3, or else it's going to be the function, the total function, the overall function is going to be undefined at this portion. And it has to be greater than 3 over 2, because if it's less than 3 over 2, so for example, if it's 0, over here we'll get the square root of 3, which is fine, but over here we'll have the square root of negative 3, which we can't do. So notice that combining these, x has to be greater than 3 over 2, but less than 3. So the way we would write that is XER, x has to be greater than or equal to 3 over 2, but less than or equal to 3. And in interval notation, the way we would show that is 3 over 2, comma 3. And it's square brackets because it can equal those values, because we can have 0 there. You can take the square root of 0. It's just going to equal 0. So we got to put these square brackets because it's inclusive of those endpoints, 3 over 2 and 3. Now, moving on to the next one, actually a lot of these functions is going to have this same domain here, so I'm just going to circle it, and I'll tell you which ones have the same. So f minus g is going to have the same domain. We're just going to have the square root of 3 minus x minus the square root of 2x minus 3. So it's a different function than this one, but same thing applies. This expression 3 minus x has to be greater than or equal to 0, and then 2x minus 3 has to be greater than or equal to 0. So this domain is actually going to be the same as this domain. It's just going to be this here, and that's the function f minus g. Now f times g, we would end up having the square root of 3 minus x times the square root of 2x minus 3. And so here we can leave it like this, but whenever you're multiplying two things under a square root, you can actually just combine them as well. That's a law that you can use. So here we can actually rewrite this as well as 3 minus x times 2x minus 3, like that. Okay, so that's another way to write this function. So just be careful, because sometimes maybe a multiple choice question might give you this function instead of this one. Okay, so just be comfortable with going from one format to the next. And then this over here, it's actually going to have the same domain. basically this expression has to be greater than or equal to 0, and then this expression has to be greater than or equal to 0 as well. And so that's going to happen in this interval. So the domain for this is the same thing. And if you were to just get this function and figure out the domain, so you'd have to figure out when is 3 minus x times 2x minus 3 greater than or equal to 0. Notice that this is just a parabola with intercepts at 3/2 and 3. And notice it's a parabola that opens down, because if we were to expand this, that leading coefficient would be negative 2x squared, so that a value is negative. So we know this is a parabola and it's opening down. These are the two intercepts, so it's going to look something like that, roughly. And so when is this expression greater than or equal to 0? Well, we could see from the diagram right here. So between 3/2 and 3, which is what I mentioned here, same domain. Okay, so we can see that with separate expressions, separate square root expressions, figuring out that this expression has to be greater than or equal to 0, or this one has to be greater than or equal to 0. But you can also look at this whole expression under the square root and then figure out when is that going to be greater than or equal to 0. When you combine them, you'll see that you get that same interval. So thought I would mention that. So for f plus g, f minus g, and then f times g, the domain is exactly the same. Now, here's where it's going to get a little different though. F over g, and then g over f. It's not actually going to be too different, but it is going to be a little bit different. So f over g, first off, let's write the function out. It's going to be the square root of 3 minus x over the square root of 2x minus 3. So that's the function right there. Now, like multiplying, if you're dividing, if I got the square root of a divided by the square root of b, I can rewrite that as a square root of a over b. So I can actually rewrite this function as this. So it might be presented in that way. So this and this are the exact same thing. Now, the domain here for this function, it's going to be different, because notice that if we look at it here, 3 minus x has to be greater than or equal to 0. Notice that the numerator can be 0, because we would have 0 divided by a number, which would give us 0. So the numerator can be 0, so we have to figure out when is 3 minus x greater than or equal to 0. We know that that is happening when x is less than or equal to 3. But what's different is now this expression can only be positive. It can't equal 0, because if it does, if 2x minus 3 equals 0 at 3/2, at an x value 3/2, then the denominator is going to be 0, and you can't divide by 0. So because this is now in a denominator, then it's not greater than or equal to 0, it's just greater than 0. So this would happen when x is greater than 3/2. So it has to be less than or equal to 3, but greater than 3/2, not inclusive of 3/2. And so that would change the domain, because now we would have x is greater than 3/2, and this wouldn't be a square bracket anymore. It'll be a circle bracket, because it's not inclusive of the 3/2. Right? So just a slight change in the domain, but nevertheless it is a change. Okay, so the domain for this is going to be different, because again, it's not inclusive of that 3/2, because that x value 3/2 is going to make that denominator equal to 0. Now, what about g over f? G over f is going to be the square root of 2x minus 3 over the square root of 3 minus x, which we can rewrite as the square root of 2x minus 3 over 3 minus x. So it can be presented this way or that way. Same sort of process as the previous function f over g. Basically, the numerator can be greater than or equal to 0, because the numerator you could take 0 divided by a number, so x is greater than or equal to 3 over 2. But in this case, 3 minus x, it can't equal 0. So we got to just figure out when is it positive, right? So if that 3 minus x was just given in a function, then that expression under the square root can be greater than or equal to 0. But in this case, that expression under the square root cannot equal 0, because if it equals 0, you'll have the square root of 0, which is 0, can't divide by 0. The denominator can't be 0. So we would end up having x is less than 3. Not inclusive of 3, just less than 3. So it's this and that. So the way that would change things is now it can be 3 over 2, but it cannot equal 3. And then over here, we would have a square bracket. And then over here, we would have a circle bracket, right? Because that x value of 3, again, it's going to make the function undefined. The denominator is going to be 0. So when you're dealing with square roots with rational expressions, if there's a square root in the denominator, then that expression under the square root has to be greater than 0. As long as you're multiplying the expression. Sometimes you might be adding expressions, so then that might be more complex. But if it's something like this, that cannot equal 0. It has to be greater than 0. So just taking that into account and just notice the difference between if these square root functions are added or if they're just in a numerator versus if you see them in denominators.